Thank you for the great introduction. And I'm Jaeman from blog.vessl.ai. And yep, so I'm gonna give a talk titled Custom LLMs, Stop Smarter, Faster, and Cheaper. So before just start my talk, I'll give you a quick introduction about myself and my company. So yeah, as I said, I'm Jaeman, I'm co-founder and the CEO of blog.vessl.ai. And I also have the other name, Kus. And actually, I was based in Seoul, South Korea, and I just relocated to United States last week. So yeah, great to meet you all. blog.vessl.ai basically merges multiple cloud platforms. So we integrate multiple cloud platforms like AWS, Google, Oracle Cloud, and then provide a control plane for machine learning computing. So we provide an interface for running any kinds of machine learning tasks from like LLM training to model deployment. So it's widely used from LLM startups who want to train their own LLM. So like we also have some enterprise customers who wants to deploy their AI models into production. And one of our customers is Hyundai Motors. They use our platform to build their autonomous driving model. And also one of our customers is like large bank. They use our platform to build their own LLM chatbot system. Let me just like jump into the main topic. I'm pretty sure that you are already familiar with what is private LLM, what is RAG, and what is fine-tuned. So I'm not gonna like go deeper, but I just like give you a brief introduction about what is private LLM. Private LLM means starting with the foundation frontier models, like such as Llama 3, Mistral, or these days, actually a few days ago, like the brand new models, such as like the name reflection. And so we can use those kind of foundation frontier models and then add our proprietary data. So you can tune your model with your data with the like open source foundation frontier model. So that's what private LLM is. So since we have ChatGPT, why do we have to build our own private LLM? So there are three main reasons. First one is privacy, and second is control, and third one is cost. So most of the like the enterprise customers care about data privacy. They have to build their own private on their own infrastructure or on their private LLM. So they don't want to take their data out of their like infrastructure. So those kind of companies need their AI systems to run on premises or at least in a private cloud. And about like control. And usually like open source LLM or like the public LLM such as ChatGPT are not familiar with the domain specific knowledge such as legal, like health, finance, or other stuff. So you have to use your own data to build your own model that fits to your business problem. And also about the cost. So let me show you this slide. So this chart shows the cost by utilization. So you can figure out that ChatGPT, the more you use it, the more expensive it becomes. So it's sometimes even 100 times more expensive when it goes to like million scale like dollars. And about performance. So this chart, you can see the like below blue line in there. So blue line is the open source model. And the performance is getting more closer to closed model, like such as GPT. And with like proper tuning and with like the advanced techniques such as like RAG, then you can get almost like much higher performance other than like ChatGPT. You can rather to use like your own like open source fine-tuned model rather than the ChatGPT. So here's the thing. So we help like tons of like hundreds of companies to run their own LLM application on production. So there are like three common phases for production LLM. So phase one is build. So you can use RAG and you can use fine tune to like tune your models to fit your business problem. And also you have to do tons of like hundreds of experiments to find the best models. And also you have to optimize and compress your models to deploy your models onto production. So once you like build, the phase two is deploy. So it's very important to like how to deploy your LLMs with reliability or scalability with maximum cost savings. So we can like handle with the compute optimization, and also we have to handle to like enterprise grade deployment, such as monitoring, auto scaling, or other stuff. And also the last one is the like automate. So we often call like it like productionize. So you have to build like automate pipeline for like automate training and deployment for like continuous deploying. ensure your AI currently. So you have to build your own like pipeline for like production AI, and also you have to build your like agent workflow to build your own LLM applications. So I will gonna like go through the three phase and dealing with the like challenges and dealing with the like tips, the how to build or how to deploy or how to automate those kind of LLM application on production. So let's start with build. So I think there are two main ways to build your own LLM. So first one is RAG and second one is fine tune. And I don't want to go detail about RAG and fine tune. So there are a lot of like experts on RAG and fine tune. But let me just give a quick overview of RAG. So RAG means that, I'm pretty sure that you already know. RAG means that you can give a like cheat sheet to like LLMs, like by building like vector database and also like other like knowledge bases. So LLM can directly reference knowledge to make responses. The information comes from the like actual knowledge bases, so the information becomes more accurate. But the common people on RAG is that there are a lot of like engineering challenges, like how to build your own knowledge bases, how to build your own RAG system. So you have to choose the right vector database. We obviously have to choose the Pinecone. You have to care about how to split data, or you have to care about how to process your data or other stuff. Luckily, we have like the like great vector database and RAG techniques, so I'm not gonna go through details about it. But here's the thing, just in the broad eye view, you have to add some layers. It can improve the actual accuracy. So just naive RAG, you can just build like vector database and you can just input the document to vector database. But to improve your like accuracy, you can add some context, you can add some like the more details, you can augment your data to get more accurate responses. So you can add some like pre-retrieval layer in here. And also post-retrieval layer, you can like re-ranking the document and other stuff to improve your actual RAG accuracy. So we call that the advanced RAG techniques with the pre-retrieval layer and post-retrieval layer. And also even you can build like modular RAG system in here. So you can make each component, whether pre-retrieval or the generation or augmentation layer as a module to make a patterned RAG technique. The modular RAG is like more common in these days to improve the RAG accuracy. So that's the brief introduction about the RAG. And there is another way to improve your private model. So fine tune is one of the other way to build your own private LLM. So RAG does not modify LLM itself. It's just giving us cheat sheet to it. But fine tuning, it actually modifies LLMs directly with the additional data sets with the domain specific knowledge. These days, RAG is more often used to build a private LLM, but fine tuning can be like worthwhile to improve performance. So if you want to add more domain expertise, or if you want to like modify the model's tone, or if you want to modify the form of the outputs, then the like fine tuning should be the worthwhile to make those kind of the like response. So let me just give you like a few experiments on fine tune and RAG and which one is the more accuracy on this experiment. Actually used the Korean criminal trial data set, and we asked the LLM to determine the fine or imprisonment with those kind of data sets. So we just use NVIDIA L4, and we only takes like 7 to 8 hours to fine tune with the Mr. 7 billion model. And the result is like this. So we scored the 50 evaluation samples on the like 0 to 2 scale. And the baseline model, just the Mr. 7 billion model, gave us around 27% accuracy. And GPT-4 like performed at like 55%. After just fine tune, our model performed better than GPT-4, especially in generating like accurate output. So only with the fine tune, you can get a better like performance compared to just ChatGPT. And how about we add RAG? So that one is the result when we add RAG, and it shows a dramatic improvement in accuracy. So here the blue bar is no RAG, and green bar is just naive RAG. And the yellow bar is advanced RAG with the like hide and re-rank and other like advanced RAG techniques. So you can see the most accurate the model with using the advanced RAG in here. So its score is about like over than 80. But you can also see there is some trade-off with the accuracy and latency in here. So the time to first token latency is much more slower when you use the advanced RAG techniques. So advanced RAG use the other LLM models like embedding model or re-ranking model or other models, or the advanced RAG have to augment the data and have to augment the context. So you need more time to generate the response. So there is some trade-off, the accuracy and latency. You should choose the right choice to fit to your business problem. And definitely you need a compression quantization to make your models faster and or to deploy your models on CPU resources. So I think this slide is one of the important slides of this talk. So here are key takeaways. First of all, so RAG and fine tune. It's easy to start, but hard to master. So first of all, so you have to prepare your data concisely. So if the garbage is in, then yeah, definitely the garbage out. So you have to care about the engineering challenges or which vector that we should choose or which embedding model should we choose or how should I chunk the documents. So we have to figure out, we have to do experiments to figure out the like parameters and configurations and other stuff. So you may need tons of LLMs for different purposes, like such as sort of embedding or re-ranking or other stuff. And you have to do hundreds or thousands of experiments to find the best model. From our experiment, fine-tuning and RAG are both essential. So fine-tuning can improve response accuracy with RAG. And also, if you want to keep enhancing your accuracy, then it comes out with a cost. So there is some trade-off between the time to first token latency and accuracy. So you have to like choose the model, the best model that fits to like your business problem. The Vessel is one of the perfect tool to run your model. First of all, we provide a Vessel hub. So it is kind of the open source model registered with runnable templates. And here's the thing. So Vessel Run is our the core concept. So we provide a YAML interface to run like LLM training or deploy AI models on any cloud. So you can see our YAML spec in here. You can specify the cluster GPU in here, and you can specify GPU resources with the spot instances. And also you can integrate the like GitHub Hugging Face or Pinecone and other stuff. And also you can specify your own command line to like specify your training or deployment or something. So we simply integrate the multiple cloud platforms in here and provide a unified interface for running any kinds of model. So you can run thousands of experiments with this tool, including RAG and fine-tune, or even compression and optimizing things to find the best model they want to use. So if you end up with build phase, so you have to go to the deployment phase. Now we are dealing with the hundreds of customers from LLM startups to enterprises. We found that there are two main considerations for deploying LLMs in real cases. So first one is compute optimization. Since LLM use really expensive compute resources, so they want to optimize their computing costs with using more cheaper cloud or using hybrid cloud or using serverless mode. And other one is there's necessaries for enterprise grade deployment, such as service reliability and observability. So about the compute optimization, I found that none of the team used only the major cloud to use GPU resources, since the major cloud GPU resources are much more expensive than other cloud platforms. So actually, we built on top of the multiple cloud platforms, we built MLOps tools on top of any cloud, so that you can find the cheapest GPUs across the multiple clouds and multiple regions. So if you want to optimize your GPU resources, GPU cost, then you rather to use the hybrid cloud, or you rather to choose some cheaper GPU clouds from Lambda or other Oracle or other cloud platform. But you have to build your own MLOps tools on top of those kind of hybrid cloud platforms. We also provide a serverless mode, and it's very useful for sparse usage pattern. One of the customers is bank, and they want to use their own on-premise machines to run LLMs. So there are very limited resources in there. So they just want to tens of the or hundreds of the LLM models on like 8 GPUs or 16 GPUs. So in that case, serverless mode is very like useful to run a lot of the like GPU, a lot of the machine workload on the like limited resources. So serverless modes can be useful for those kind of enterprise like users. So yeah, as I said, the best option is Vessel because it's cloud agnostic and it actually like connect to like multiple cloud platforms in here. And yeah, just provide a unified interface for running any kinds of machine learning tasks. We also offer the GPUs from our end, and it's much more cheaper than like Lambda Cross since we have some strategic partnerships with the local cloud platforms. So we built on top of the like the Oracle, Lambda, or other local cloud platforms. Then we can like provide our GPU resources like much more like effective way. It's about like the hybrid cloud and serverless mode. And about the enterprise grade like deployment, you may need the service reliability, including auto scaling and monitoring performance and other stuff. And also you have to observe your models. You have to monitor your model and update based on the user feedback. So we actually offer the serving features. So all you need to do is to just like specify the service part in here. So you can specify auto scaling, monitoring, and all other stuff. So it's quite a same like YAML interface. So you can run on any cloud, like with advanced features like auto scale, model routing, revision, and other stuff. So we also have some dashboard to show you logs and system metrics and model metrics in here. So that's the two major consideration when you deploy your LLMs on the production. So first one is the cost optimization, compute optimization, and second one is the how to deploy your models with the full reliability and scalability. And after that, you have to actually the productionize. So you have to automate your like model training and model deployment. And this one is the much more important when you build your LLM application on your product into production. So when we build Gen AI application for prototype, it's quite easy to make. It even takes like 1 week or 2 weeks to make the first application. So we can choose the LLM and we can choose the vector database. We can build our knowledge base and we can just like building some Gen AI applications for like just for prototype. But actually, you cannot use those like prototype to your production. There are a lot of like significant engineering for like production Gen AI application. This image is from Iguazio, which is one of the other wonderful MLOps tools. It says that you may need like multiple pipelines for productionize your LLM application. So here's our like customer story. One of our customers is Hyundai Motors. They already built their own autonomous driving model on their own hand, but the data comes on daily basis. Like there are several teams to build the model to handle the whole like process, like data collection, data pre-process, and model training, evaluation, and other stuff. The data comes on daily basis. They cannot do any other work for a year. They just like update their models with newly come data. They need some like this kind of automated pipeline, machine learning pipeline to update their model automatically. And the one other is the bank, and they want to build their own LLM chatbot with their internal data. So they actually succeeded with the like building the first prototype of the chatbot with their internal data. But after 6 months, they cannot use that since chatbot responses cannot reflect the like newly come update data. They have to build those kind of the ML pipeline to ensure bot correctness, to answer with most recent data. So on production, you have to build this kind of pipeline to actually run your Gen AI application. So here's the sample architecture for private LLM. We built like 3 different types of the pipeline in here. First one is indexing pipeline. So when the data comes in, we automatically process data and we automatically embed the data and we store the data. We store the vector database. And also we like periodically fine-tune, train models, private LLM models. And then if the private LLM models, if the newly updated like private LLM models, like the accuracy is like great, then we just build like automated deployment pipeline for actual service. So it's quite a simple and sample architecture for private LLM deployments. So you may need those kind of ML pipeline for your production GenAI application. The one comprehensive solution is the Vessel pipeline. So you just drag and drop and build your own pipeline for every step. So you can build your data process pipeline. You can build your own model training pipeline, and also you can build your own model deployment pipeline with Vessel pipeline. Hyundai Motors use this feature to automate their autonomous driving model. So to summarize, I've been talking about like how to build, deploy, and automate the LLM and common pitfalls in production AI. And we've been working on this topic for 4 years, and we are solving these challenges with 2 components. First one is Vessel Run. So we provide a unified interface for running any kinds of machine learning tasks on any cloud. And second one is like Vessel pipeline. So it can automate the every step of AI development. Conclusion. So let me just summarize the beginning part. So fine tuning and RAG both have their trade-off, but combining the fine-tune and RAG can yield better result than GPT-4 in specific domain. And we even got those like private LLM model, fine-tuned private LLM model with only like 7-8 hours with the like NVIDIA L4. So you can get great like your own private LLM only with the cost under than $100. So you can even like use the RAG and fine tune to build your own like private LLM, and also you may need some kinds of like automate pipeline to deploy your models and to run your LLM application on the production. I think I almost cover all of my topics, so feel free to ask any question after this presentation if you're interested in our platform. So I can cover like 2 or 3 questions for now. So if you have any question, please let me know. Actually, we are like ISO compliant, so we are working on the like, SOC 2, and yeah, we are also working on the HIPAA compliance.
Thanks. So does it work with on-prem systems? Is there an agent, or is this a cloud only?
Yeah, so actually there are 2 ways to use the on-premise clusters. So you can connect your own clusters to our like SaaS version, or we also support the on-premise installation for air-gapped installation. No, so it just installed on top of the Kubernetes system. So yeah, if you have the like Linux OS, then yeah, it's fine.
Thank you for your presentation. My question is, within the enterprise, if there's a corporate library of PDF documents in all modalities, each document is perhaps 1,000 pages, 100 documents. What's your thought on how to prepare for services like you're offering?
Yep. So you may need like many components to process those kind of the PDF documents. We care about the computing resources and the computing infrastructure for running LLM. So you may need like proper embedding model to make your like PDF document to vector, and you may need like vector database such as Pinecone. And we can run like embedding model, and then also we can run private LLM, and we can manage those kind of like training, fine tuning, deployment stuff on our platform.
So you spoke about the in the deployment phase, the hybrid cloud, which is provided by Vessel AI. So does that mean you use different cloud providers in different stages of development of GenAI application, or?
Yeah, actually, we are working with the many cloud platforms such as like the AWS, Google Cloud, Oracle, and even we can working on the on-premise machines. So any cloud platforms works well with our platform, since we built on top of the Kubernetes clusters. And also we can make the like deployment side on top of the like on-premise machines, on-premise clusters. We can handle that on our platform side.
So for different stages, like for fine tuning and for inference, so you're using different cloud providers to reduce the cost?
Yep. So that's actually the common use cases. Most of our customers wants to train their models on the on-premise machines, since the cloud GPUs is too expensive to use the training. So you can use your on-premise machines, or you can use cheaper cloud platforms, Lambda, for training, and then you can move that model. You can just switch the cloud platforms for your deployment. So that's very like common use cases. And also you can use like different cloud platforms and multiple cloud platforms for like training, just for one training. So you can pre-training from the AWS, and then you can move in your model to like Oracle. That's also possible, but that's not that common. Yep. So thank you for listening. Thank you.